Okay, so this is question 4 on the G484 mock paper. So in part A, we are asked to define the term geostationary orbit. A geostationary orbit is an orbit that is above the equator, and the orbit is in the same direction of the spin of the Earth, with a period of 1 day. Easy 1-mark definition question to get started with. So in part B, we are told in a science fiction movie, a spaceship approaches a planet called Benzar, and the rotation of Benzar is 1.2 times 10 to the 5 seconds. The captain of the spaceship orders the crew to enter a stationary orbit above the South Pole. Use your knowledge of physics to explain why this is impossible. Well, in the previous question, we said that the definition of geostationary orbit is an orbit above the equator, and the South Pole is not on the equator, so if it's above the South Pole, it can't be above the equator. And then this is 2-mark question, so we will need to have a second point for a second mark. So another point would be that the spaceship must orbit in the same direction, and if it's above the South Pole, it can't orbit in the same direction as the planet spins.
Okay, so now we're moving on to part part 2. And it says Benzar has a mass of 8.9 times 10 to the 25 kilograms. Calculate the radius of the possible stationary orbit of a spaceship circling Benzar. So the key thing to realise in this question is which equation to use. So as we can see here, we've been given the mass, which I've just shown you, and also up here we've been given the period of Benzar's rotation. So we have period, we have mass, and we want radius. So the equation which we need to use is Kepler's third law, t squared equals 4 pi squared over gm r cubed. So the next stage after that is bringing in your values. So as you can see over here, we've got the period of 1.2 times 10 to the 5. Here we've got the gravitational constant of 6.67 times 10 to the minus 11. And then we've got the mass of the planet, which is 8.9 times 10 to the 25, all divided by 4 pi squared, and then times by r cubed. So we move down to the next part of the question. And as you can see here, all that's happened is I have divided this both sides by r cubed, so that we now get 1.45 times 10 to the 10, which is 1.2 times 10 to the 5 squared, divided by the r cubed, gets it away from this side, and then the 5.94 times 10 to the 15 comes from 6.67 times 10 to the minus 11, times by 8.9 times 10 to the 25. So after the next step for that is I move the r cubed again, move it across back to the other side, and then we move the 5.9 times 10 to the 15 across to the other side, timesing that by the 1.44 times 10 to the 10, which gives 8.55 times 10 to the 25 equals 4 pi squared r cubed. The next step after that is to take your r cubed and divide both sides by 4 pi squared, which gives you a value of 2.17 times 10 to the 24. And then we just cube root our value of 2.17 times 10 to the 24, and that will give us our value for r, which is 1.29 times 10 to the 8, and that goes down here on the answer box. So that is G484 question 4.